Now, so far we've seen a lot of similarities between tuples and lists, but unlike lists, tuples are immutable. Now that means that elements of a tuple cannot be changed once they've been assigned, whereas we can change elements of a list. So for example, let's take the tuple that we created in the last video. So if we access the first element of this tuple, we would put my_tuple, and inside square brackets we would put 0. Now if this was a list, we can then put the assignment operator and then choose what to assign this element in the list. However, with tuples, if we try to assign this a new value, for example the string hello, you can see we run into a type error, telling us that the tuple object does not support item assignment. This is what we mean by immutable. The elements cannot be changed. However, if the element inside the tuple itself is a mutable data type like a list, i.e. the nested item, then the nested item can be changed. So you can see here we have a list inside of this tuple. So if we access this list, we can put my_tuple, and in square brackets we would put index 5, seeing as it's the 6th element. This will bring back the list. If we now want to change the value 8 to be the value 80, we can then use nested indexing by placing another set of square brackets and then putting the index 2, as 8 is the 3rd element in the nested list. If we assign this to be the value of 80, when we take a look at my_tuple, we can see that the value 8 inside of the mutable list object has been changed to 80. Now let's think about this for a second. Why can we do this? Well, if we think about it, as soon as we access my_tuple and put in index 5 in square brackets, we have returned a list object. So we can now chain list methods to the end of this indexing because we're now working with a list object. So if I wanted to add an element to this mutable list, even though it resides inside of a tuple, we can do so. So if I was to put my_tuple square brackets 5 and then put dot append, we can add another item to this list. So let's add the value 100. When we now run my_tuple, you can see that 100 has been appended to the list object which resides inside the tuple. So note here that if we try to change an element inside of a tuple element, we will get a type error, as tuples are immutable objects. Whereas if the tuple itself contains an element which is of a mutable data type like a list, we're able to change the items in that element specifically. Now, if we wanted to change the values of a tuple, the way we can change them is by reassigning values. So here, if I type my tuple, you can see we have a long list which starts with 5 integers. Now, if I were to put my_tuple and then assign this a new tuple which contains 3 strings, so we'll put 1, 2, and 3. We have now changed the items stored inside my_tuple, but this is reassigning a completely new tuple to this variable. So we haven't changed the original object, we've actually assigned it a new tuple. Now a couple of other things we can do. If I type out my tuple, I have 3 elements within it. Now I can use the plus operator to add more elements to it. So if I put my_tuple and then put plus, I can then add 3 new items to our tuple by first providing brackets and then putting strings such as 4, 5, and 6. Now when we use the plus operator to combine 2 tuples, it's known as concatenation. So what we've actually done here is brought back a new tuple. This won't be stored anywhere unless we assign this to a new variable. So once again, we haven't changed the original tuple, we've simply concatenated another tuple, but then we would need to reassign this to a variable, so let's call it my_tuple_1, and now whenever we access this new variable, we have the 6 elements accordingly. Now another thing we can do is use the star syntax to bring back a new tuple. So for example, If I take the original my underscore tuple, which has 1, 2, and 3 stored inside of it as strings, if I multiply this by 2, we get the sequence of 1, 2, and 3 twice within our tuple. And if we wanted to, we could assign this to a new variable and then use it later in our code. So remember, tuples themselves are immutable objects. We're unable to change the elements once they've been assigned. However, if there is a nested element inside of the tuple which is of a mutable nature, such as a list, we're able to change the list's elements. For tuples, we can use concatenation to add values to our tuple, but we'd need to reassign or assign this to a variable. And the same with the multiplication, we're able to repeat elements in a tuple, but this brings back a new tuple, and we need to reassign or assign this to a variable in order to use it later in our code. As we've just discussed, we cannot change the elements in a tuple. That also means we can't remove or delete items from a tuple. So this video will be slightly shorter than all the rest. So for example, if we access the first element by typing my tuple square brackets 0, and then putting the del keyword before it, you can see we run into a type error telling us that the tuple object doesn't support item deletion. But it is possible to delete a tuple in its entirety. So if we were to put del followed by my underscore tuple, if we now try to reference my underscore tuple, we can see that the name my tuple is not defined. So we've deleted the entire tuple object and it can no longer be referenced anywhere in our code. So to summarize, we can't delete specific elements from a tuple, but we can delete the tuple object in its entirety by preceding the variable name which stores the tuple object with the keyword del. Now, seeing as tuples are immutable objects, there isn't too much we can do with them. So the good news is there are actually only two methods we can call on a tuple object. So let's first of all create my underscore tuple, and we'll set this equal to a tuple of integers, and we'll put 1, 1, 1, 1, 2, 3, 4, and then 1 and 1. Now the two methods we have available to us are count and index. So if we first of all call the count method on the myTuple variable which stores a tuple object, inside these parentheses we can pass in the value that we want to be counted within the tuple. So if we put the integer 1 as an example, we return 6 as there are 6 elements inside of this tuple that are of the integer 1. So inside this count method we can pass in a value, whether that be an integer or a string, and it will count the number of elements that equal that value. Now the second method we can call is the index method, and this will bring back the index of the first occurrence of the value that you put within the parentheses. So if we put my underscore tuple, then our dot, then index, and then inside square brackets put the value 2. Before we run this, we can see that the index of the value 2 is actually index 4 because it's element 5. So when we run this code, we do indeed bring back the index value 4. Now if I change this 2 to be the value 1, you can see that we get index 0 as it brings back the index of the first occurrence of this value. Now we've seen before that we can pass in a second argument to the index parameter, which is whereabouts in the sequence we want to start the method from. So if I put 5 as the second argument, you can see that it brings back index 7. This is because it's starting from element 6 and the first occurrence of 1 then occurs where that occurrence of 1 is at index 7. So we can either pass in one argument, which will pick up the first occurrence of the value from the start of the tuple, or we can pass in a second argument in addition to the first, which will change whereabouts the search starts from. Now one other thing I want to show you, which we've already seen before, is tuple membership. So we can see whether a value exists in a tuple or not in a very similar way to how we've seen with lists. And this is done by using the in operator. So we can put 1 in my tuple, and of course this is true, there are many of them. We can then put 5 in my tuple, and because 5 does not exist as an element inside this tuple, it brings back false. Now we can also use the not in operator, so if I change 5 in my tuple to be 5 not in my tuple, we then obtain the value true. And this comes in very useful when it comes to conditional statements, which we'll see in a subsequent section. So remember, there are two methods we can use: count, which counts the value that you stipulate within the tuple itself, and index, which brings back the first occurrence of the value that you stipulate back as an index. We can also use tuple membership, where we simply use the in operator or not in operator to ascertain whether a value is inside the tuple or not. Now you may recall from a prior video the concept of tuple packing. If not, don't worry, let me quickly remind you. Now I can create a variable called my_tuple, and I'm able to create a tuple by simply putting the values that I want to include. So I can put 1, 2, then a string hello, then a floating point number of 2.5. Now when I print out my_tuple, you can see we return a tuple based on the brackets, but just to prove it, I can put my tuple inside of the built-in type function, and we get tuple returned. Now once we have all of the elements inside the tuple, we can carry out a reverse operation which unpacks the elements and stores them in individual variables. So seeing as we have 4 elements inside this tuple, I'm able to create 4 variable names on the left hand side of an assignment operator. So if I simply put A, B, C and D separated by commas, I can set this equal to my_tuple. And what this will do is it will take the first element in the tuple and assign it to the variable name A. The second element will be assigned to B, and so on. So if I now take a look and see what's stored in the variable named A, you can see we get 1 returned. And if I take a look what's stored in C, we get hello, D, we get 2.5. Now one thing to note here is that we need to provide the same amount of variables on the left hand side of our assignment operator compared to the number of elements stored in the tuple. So seeing as this tuple has 4 elements, if I were to only stipulate 3 variable names on the left hand side of the equal sign, you can see we run into a value error, and it tells us that there are too many values to unpack. We're expecting 3 based on the stipulation of 3 variable names, but there are actually 4 inside of the tuple. So tuple unpacking is a very useful way of being able to take elements stored inside of a tuple and assigning them to different variable names. So practice creating a tuple using tuple packing, and then unpacking into different variable names based on the number of elements that are inside the tuple. Now sometimes it can be a little confusing as to when to use lists and when to use tuples. Since tuples are quite similar to lists, both of them are used in similar situations. However, there are certain advantages of implementing a tuple over a list. So let me give you some of the main advantages. Now firstly, we generally use tuples for heterogeneous data types, which basically means we store different data types within them. Now lists, however, are usually used for homogeneous data types, so types which are similar or the same in nature. Now this will become very apparent if you start diving into the world of data analytics using libraries such as pandas, but we can save this for another course. So when storing items in a tuple or a list, work out whether they will store different types. If it's the same type, then a list will usually be the better option. If they are of a different type, then a tuple usually works better. Now secondly, since tuples are immutable, iterating through a tuple is actually faster to perform than iterating through a list. Now the difference is hardly noticeable on small datasets, but it can save time on larger stores of data. Now we will explore the concept of iteration when we get to the control flow section, so keep this performance benefit in mind. Now thirdly, tuples that contain immutable elements, so things like integers or strings, can be used as a key for a dictionary. So let me show you what I mean. If I create a dictionary called my_dict, and I set this to a set of curly braces, inside of this dictionary I can now type a key and a value. For the key, I'm going to create a tuple with the values 1, 2, and 3. I can then put a colon, and for the value, I will simply put the string hello. When we run my_dict, you can see that we get a valid dictionary. And if I was to try to access the value that's associated with the tuple with the values 1, 2, 3, I'm able to place this inside square brackets, and you can see that we obtain the value hello. Now, if I go back up to the original dictionary definition and replace the brackets for square brackets, you can see we run into a type error, and it states that we're working with an unhashable type list. Now, I've included some documentation in the resources section if you're keen to explore what this error means. Now, a simple way to think of when to use a tuple versus a list is as follows. Do I want the data inside the data structure to change? If you have data that doesn't change, implementing it as a tuple will guarantee that it remains write protected, as it is immutable and you can't change it. If you want more flexibility and you want the values inside of the data structure to change, then storing in a list would be better as they are mutable objects.